Hi guys, welcome back to some more video notes. Our next unit is Unit 3 and it's solving systems of equations and inequalities. So just when you thought we were done with linear equations, we are not. We have another relatively short unit on graphing systems of equations, and systems of equations just means two or more linear equations, and for our unit we're going to focus just on two. So a system of linear equations, what is the definition? A system of linear equations is two or more linear equations. And by linear, we mean y equals mx plus b. And we just focus on two linear equations. To solve a system of linear equations, that's any ordered pair, an x and a y, that works in both equations. And so when we have a system of linear equations, there's only one set of ordered pairs that will work in both. So what does this all mean? So let's take a look at this example right here. We're going to solve this system of linear equations. I'm looking for an ordered pair in the form of x and y that will work in this equation and in this equation. It has to be the same x and the same y that works in both equations. So the first thing we're going to do is go ahead and graph these using the y-intercept and the slope, and I'm going to graph them in two different colors. So I will graph this one in red, and I will graph 1/4 x minus 4 in blue. So keep in mind we start with the y-intercept, and for our first equation that's at -1, and our slope is -1/2, so it's down 1 and over 2. And we have to make sure that this is going downhill. And we can go in the opposite direction. We can go up 1 and left. And there's our graph for y equals -1/2 x minus 1. I'm going to do the same thing for 1/4 x minus 4. So my y-intercept is down here at -4. My slope is 1/4, so I'm going to count up 1 and over 1, 2, 3, 4. And it happens to overlap that point right there. So up 1 and over 1, 2, 3, 4. And I can go in the opposite direction. I can go down 1 and to the left 4. And I can go down 1 and to the left 4. So if we look at this point right here, that was a point that was both red and blue. So that is the one point, and that's 4, -3, that both of these lines have in common. So that point, -4, -3, it's on both lines. And how do we know that? Because our lines went through that point. And it's also the point of intersection for both of these linear equations. And that's what we're looking for. This point right there is what we're going to call our solution. So it's one equation, or one ordered pair, that works in both -1/2 x minus 1 and 1/4 x minus 4. So how can we show that? Well, I'm going to take this point, 4, -3, and if I plug in 4 for x, I should get -3 for y. So let's do that in the first equation. So if I plug in -3 for y, is that the same as -1/2 times 4 minus 1? I get -3 equals -2 minus 1, and that works. If I do it for the second equation, I want to do the same thing. I'm going to plug in and again that works. I'm going to plug in -3 for y, and is that the same thing as 1/4 times 4 minus 3? So is -3 the same thing, sorry, minus 4, the same thing as 1 minus 4? And it is. So this ordered pair for -3 works in this equation, and it works in that equation. So let's take a look at example number 2. We're going to do the same thing. We're going to graph this equation, y equals -2 halves, or -2x plus 2, on this graph over here. It's a -2, so it's down 2 and over 1. Remember that has a slope of 2 over 1. So it's down 2 and over 1, and we keep on doing that until we fill out the graph, and we can go in the opposite direction, up 2 and over 1. So when we graph this one, we want to see what point on this graph will this line right here intersect. So this has a slope of, or y-intercept of -2. It also has a slope of -2 over 1. So we're going to count down 2 and over 1. And so far they're not intersecting, up 2 and over 1. So these lines do not intersect. So if you look at their slopes, if you remember from part 2 in unit 2, these have the same slope. So what does that mean? That means the lines are parallel. Nope, I guess I should put it here. Therefore, this systems of an equation has no solution because they will never intersect. There's no set of ordered pairs that will work in both of them, because these two lines are never gonna meet. So what do you look for in order to identify these types of lines? You look for equal slopes. Equal slopes means that they are parallel. And since the lines never intersect, this system of linear equations has no solution. So let's go back up here and look at question number 1. Question number 1, this had one solution because they intersected at one point. Question number 2 had no solution because they were parallel lines and they never intersected. So let's take a look at one more type of graph. So if we have a systems of linear equations where they intersect at one point, and then we have a system where they never intersect, which means they're parallel, we're going to take a look at this set of equations. 2x equals, it should be 2x plus y equals 6, and y equals -2x plus 6. And we want to graph both these equations. But first, we have to put this equation in y equals form. So if we subtract 2x from each side, this one we get y equals -2x plus 6. So if we graph that one, and again we're going to graph using the y-intercept, which is +6, and then our slope is -2, so it's down 2 into the left 1, down 2 into the left, down 2 into the left, and we can keep on going with that. Or we can go up 2 and to the right. If we're going to graph this one, that happens to be the same line. So our y-intercept is still +6. we're still going down 2 and to the left, down 2 and to the, down 2 and to the right, down 2 and to the right, down 2 and to the right. So what happens is these are the same line. So that means that all ordered pairs will work because they're the same line. So just like when we're solving equations, we have equations that have one solution, that have infinite solutions, and that have no solutions. This type of systems of linear equations, where they're both the same line, is what we call infinite solutions. Or infinitely many solutions. So let's take a look at this summary right here. So this is a summary of the three types of solutions. The lines can intersect in one point. The lines can be parallel, which means they'll never intersect. Or the lines can be the same line. We call those coincident lines or coinciding lines. I mean, they're the same thing. So if the lines are intersecting, there's one solution. The slopes are different, and the y-intercepts are different. So that would be like our first equations, where we had y equals -1/2 x minus 1, and y equals 1/4 x minus 4. The slopes are different. They have different slopes, and they have different y-intercepts. Our second type of solution are parallel lines. Parallel lines have no solution, and they have no solution because they're parallel, or they have zero solutions. The slopes are the same, and the y-intercepts are different. So let's take a look back at example number 2. We had the line y equals -2x plus 2, and then y equals -2x minus 2. So we had the same slope, but we had different y-intercepts. And then finally, the last example, coincident or same lines. This is infinite solutions. And these lines have the same slope and the same y-intercept. So in example 3, our lines were y equals -2x plus 6, and y equals -2x plus 6. And the first one, keep in mind, was originally 2x plus y equals 6. These are the same equation. So we're going to practice with graphing lines in class tomorrow. We're going to look for lines that have intersecting lines. So this is the solution right here. And they may intersect at perpendicular points, they may not. Some may have no solution, which means they have parallel lines, and some may have infinite solutions where they have, it's the same exact line. Okay? There is no Google form tonight. We're going to do those 2 Google questions in class tomorrow. So no Google form. I'm just going to check for the notes. Have a good night.